Hello, Professor.
Hey, how you doing? Let me go back to see. Let me just give me one sec. Let me mm. Hey, Michael. I see you there. Pretty
Hello.
good. Is that Michael?
Yeah, hey.
Hey, pretty good. Hey, we're just getting ready for the lecture.
All right.
Glad to hear you guys and see you guys.
Oh, you need to be able to see us?
No, not at all. If you don't
Okay.
want to, that's okay. As long as I can hear you, that would be.
No,
And
my
also,
sister is taking online classes too. I let her borrow my webcam since she needs it. But
oh, perfect. No, that's perfect. Okay, you guys, as long as I can hear you, any questions that you might have, and you guys can hear me, that would be good enough.
yeah, sure. Okay.
Yeah,
I'm
pretty
glad
good.
you're recording the sessions.
Yes, I am actually.
My chemistry teacher neglected to do that. We only figured out that you have to enable it beforehand. So,
Yeah, you guys can see me there.
oh, hello. Yeah.
All right, sounds good. Yeah, I'm gonna be recording all these sections, and probably later on I'm gonna upload it to
Just for like absentee
yeah,
or
YouTube, yeah, and just give you
I
the
think
link.
YouTube's the way to go.
Yeah, that would be a good idea. Let me see here. Okay.
This to sound a lot better than my chem professor. Her mic wasn't too great.
Yeah, so I'm using this cam right now, and probably not bad. I think that uh, yeah, we're getting ready. Michael, how did exam 2 go?
Oh, well, I guess.
All right, pretty good, pretty good. I think that was fair, and good thing that you guys had all the resources
Yeah.
with you guys. All right, pretty good. Already, I'm just getting
I had some problem
all
with the
set.
first one, finding the derivative, but I mean, I bet most people did.
Finding the derivative. How come you got into now calculus?
I had time, so I looked it up, but
Oh,
honestly, you can
okay.
mark me off for it. This is me letting you
No,
know.
no,
Yeah.
no. That's cool. I just what is it that you were finding that you had to use calculus? By the way, I'm curious now.
Oh, finding the range for the function, it was x minus 2 times x minus 4 over x squared minus 36 was the first problem.
Oh, I
And
see.
yeah, I
Okay.
had from what I understood, we had as much time, so I
Yeah,
just
definitely.
looked
Yeah,
at
you
that
know
up.
what? I'm gonna look into it, and that would be interesting. I mean,
If I wasn't supposed to do that, then
no, that's cool with me. I mean, if you
I
guys,
don't. Honestly, I didn't remember covering it. So if we're not supposed to do that, then
no, that's okay. That's okay with me. I know, as long as you guys know what you guys doing, and that's cool with me.
okay,
And so you guys moving ahead of, that's cool. No problem. No problem at all.
okay.
That really works for me. All right. So I think that we're getting ready. It seems like we're all set. Uh, all right. Pretty good. And the good thing is that we're going to be able to also all right. So I hear a couple of little kids back there. Pretty good. uh, which is normal sometimes.
Is that on
Uh,
your end?
is it on my end? No, probably somebody else is who is connecting with us might have some kids.
Huh.
Yeah, that sometimes it is interesting.
Yeah,
Some of you have family, and which is normal.
cute little humans running around.
Yeah, definitely. They show up unexpectedly. And we're gonna be able to also chat, by the way, which is pretty good. Pretty good, pretty good. All right, so. So, Michael, you're taking another class online, you said?
Yeah, the my chem course, it's going online too.
Wow. Uh, it might be interesting also. That class is a little bit interesting, isn't it?
Yeah, I like it.
Pretty good. You know,
Doing lab online is going to be a bit tedious since we're not actually able to mess with anything.
yeah, so that's going to be a good change, big change for that kind of classes where you guys have to show up probably for lab, like physically showing, right?
Since we can't do the experiments, we're just given results. It's like, yeah, do something with this. Good luck, kid.
Yeah, yeah. That's pretty cool.
I imagine most of the professors are having to find a way to bridge the gap, so part for the course, really.
Yeah, by the way, yeah, we are probably we're gonna be short 1 week, so we have to make up for that week. But we're gonna be able to, definitely.
I thought we'd skip spring break
No,
since we did just get a week off, whether intentional or not.
no, I believe that we're keeping a spring break
I saw the
unless,
schedule. It looks like it's still there, but
yeah, so far it's still there. So unless they change their mind. So as far as I know, at this point, we're still keeping it. I'm gonna get an extra book. I'll be right back.
yeah, sure thing. This is why we needed a sine calculator. Hey, everybody else. I was talking to Professor, but you guys are all in here. Neat.
It's nice to hear some music back there. Pretty good.
It's at the instructor's textbook. Neat.
If you guys are able to hear me, then you're fine and see me. All right, so how's everybody doing?
All right. Yeah, all right.
All right.
A little good, I guess.
Hey,
Had some issues uploading the exam, but it's all right.
yeah, you guys need more time to upload it. Yeah, let me know, okay? So,
Yeah, I was stop, please. Like, I was uploading it at like 2 minutes before the up. 1 second.
yeah, I can extend the time, yeah, definitely.
All right, thank you. Sorry about that. It's my dog. I'm trying to get it to calm down.
Yeah, I wonder if everybody hears, or just myself hears your dog, or everybody does else. I'm not sure.
I'm pretty sure everyone can hear it. Or I don't know. Can you guys hear
Okay,
it?
so no, I'm not
Yeah,
sure.
it's shared between everyone.
Really? Oh, okay, okay. That's interesting.
Yeah.
All right, yeah, pretty good.
All right, my bad. I'll
Definitely.
just mute myself.
Sounds cute.
Yeah, definitely. All right, let's see how many are going to be able to join us today. All right, so I'm gonna ask you to have your, I don't know, you guys were able to download your handouts from Canvas. And I'm gonna be using the same handouts that I uploaded to Canvas here for the lectures, by the way. So my goal is gonna be that let's see how this works with the handouts that I'm giving you. If that works fine, then I'm gonna keep this way, or I'm gonna make some changes later on. But definitely, I'm gonna try to better my my writing, you guys. Definitely, that's one of my goals here. Okay. So definitely. So it is 5:30. You guys, again, welcome. Again, you can ask questions. Also, there's a way to chat if you guys have any questions. Also, let's see. All right, perfect. All right, so I see you here. Very good. All right, perfect, you guys. So, Mandip, I wonder if you can hear us now.
Professor,
Yes.
I have a quick question. So for
Sure.
exam 2, even though it was turned in online, are we still able to do test corrections or exam corrections on those,
No,
or
not
those
anymore,
are
you
different?
guys. No, yeah. The thing is the time. Yeah. So,
Okay.
so hopefully you guys gonna take advantage of all the resources that you have there at home. So yeah. I wish I could tell you yes, but it might not be possible anymore.
I understand.
Just
I was
to
just
let you
curious.
know. Yeah, no problem. All right, you guys. Hopefully you guys have your handout in front of you, 6.1. So now we're gonna start a section of trig. That's where we're gonna start. So and let's start with 6.1 and notice the title of its angles and they're measured. And the objectives are convert between decimals and degrees, minutes, seconds, measures for angles, and the second one would be convert from degrees to radians and from radians to degrees. All right, so the first thing that we're gonna do is we're gonna start with the definition of a ray. Well, a ray is just a line, and if you notice in one of the sides of the line, we have an end point, which this is known as the vertex, and the other side, it goes indefinitely in the other side. So that's a ray. So when we connect two rays together, now we form an angle. And notice that the common point of the two rays is known as the vertex, and also one of the sides is known as the initial side, and the other one is going to be the terminal side, the initial side and the terminal side. So notice also that we form an angle between these two sides. Here I'm using theta, one of the Greek letters that we're going to be using. And in trig, we're going to be using the standard form of an angle. And how do we form the standard form of an angle is that the initial side is always along the x-axis all the time. And the terminal side could be in any of the quadrants, or it can be either in one of the axes by itself. For example, for this one, the figure on the left side, if the angle goes counterclockwise, this angle is a positive angle right there. And the other case would be when the initial side is also along the x-axis. All the time the initial side is along the x-axis. And notice now the terminal side is also in any quadrant, but notice that now that the direction of the angle is clockwise. And when we go on this direction, theta is negative. All right, so let me know if you guys have any questions. Seems that it's pretty easy concepts to understand. So I'm gonna continue with the next page. So here, some of the Greek letters that we're gonna be using to show or denote angles, we have theta, beta, gamma, and alpha. So I can use any of these, or you guys can use any of these Greek letters to show the measure of an angle. So let's try some exercises to draw some angles in degrees. By the way, we're gonna learn that angles can be measured in degrees or radians. Let's start with degrees. Notice, draw the following angles in degrees. And if we start on the left side, we have a 30-degree angle. Just to give you an idea, you know, we know that if I have an angle that it goes, let's say it starts at the initial side and goes all the way around, that's known as a revolution, and that would be 360 degrees, by the way. So probably most of you also know that, for example, the angle between from the x-axis to the y-axis is a 90-degree angle, by the way. Well, just by using my 20/20 here, notice I have a 30-degree angle right here, you know, and this is known as a positive 30-degree angle. Notice for B is a negative 120-degree angle. So notice now the direction of the angle. I start at the initial side along the x-axis, and now I go clockwise. And that shows me that it's going to be a negative 120 degrees. So let's go over C. Let me just go here. Let me see if one of you have any questions. All right. Okay, perfect. So I'm going to be checking in case you guys have any questions. Okay. Notice, let's go over C. 540 degrees. So how do we find, or how do we know how to draw that angle now that is 540 degrees? Well, something that we know, as I mentioned, that we know that a revolution is 360 degrees. What if we subtract 360 degrees from 540? Well, let me try it right now. 540 minus 360. Notice that I'm left with 180. So if I go one revolution, if I start right here at the initial side, if I go one revolution is right here, which is 360. And then I need to go 180 more. So from here all the way to the other side along the x-axis, that will be the extra 180 degrees. So total now I have 540, right? So let me know if you have any questions let me go over the chart. And if not, we're moving on. Let's continue here. All right. Now let's convert between decimals and degrees, minutes, and seconds. Well, most of us, we are used to the angles be measured just in degrees, like the exercise that we did. But in some applications in real world, we want to be more specific, more exact. And then we start using minutes and seconds. For example, for locations, we start using minutes and seconds to find the exact location. So let's go over these conversions right here. Notice, let me start with this one. 1 degree is equals to 60 minutes. And if we solve for 1 minute is equals to 1 over 60 of a degree. And 1 second is 1 over 60 of a minute. This is a minute. And also notice that I know that 1 minute is 1 over 60 of a degree. And if I use that, this relation right here, and I substitute instead of 1 minute here, 1 second is also equals to 1 over 60 times over 160 of a degree, which becomes 1 second is equals to 1 over 3600 of a degree. Keep that also in mind that 1 minute is equals to 60 seconds, as we know. All right, so let's use this these relationships, and let's try this this exercise right now. It says, excuse me, convert each angle to a decimal in degrees. Round to 2 decimal places. So let's start with the one on the left, which is A, right there. Notice I got 40 degrees, 10 minutes, and 25 seconds. First thing that I'm gonna do, I'm gonna rewrite it in this form, which is equivalent. 40 degrees plus 10 minutes plus 25 seconds. So remember, I want to convert to only degrees. Well, here, if I rewrite it again as 40 degrees plus, notice I got 10 minutes, excuse me, but 1 minute, we know that 1 minute is equals to 1 over 60 of a degree. I can substitute that plus 25 seconds, and I know that 1 second is equals to 1 over 3600 of a degree. And doing the math here, I can also rewrite as 40 degrees plus 10 over 60 of a degree plus 25 over 3600 of a degree. You guys can enter everything in your calculator. Hopefully you guys have your calculator with you guys and give it a try. You can enter it in one single line or row. And if you round to 2 decimal places, you should get 40.17 degrees. So let me just wait a minute here for you to try it. All right. Okay, so let's continue with B. B, same steps, exactly the same steps. B is 50 degrees, 40 minutes, 20 seconds. Again, I rewrite it as 50 degrees plus 14 minutes plus 20 seconds. Here, notice I just write it straight as 50 degrees plus 14 over 60 of a degree plus 20 over 3600 of a degree. One single step here. Use your calculator and the answer would be 50.24 degrees. So let me wait 1 minute. You guys try in your calculator. You just want to make sure that you guys getting these values. I'm gonna be checking now and then for the chat in case you guys have any questions. You can unmute you also your mic and ask questions. Feel free. All right, perfect. All right, so let's continue. All right, so let's continue with, now we're gonna do the other way around. Now let's convert each angle to a decimal in degrees. Convert, this is the one that we did already. Well, I do have another exercise. You know what? Let's see. I think that we did this one already. Let me continue with the one right here. Okay. All right. Here we're going to do the other way around. We're going to convert each angle to degrees, minutes, and seconds. Round your answer to the nearest second. Now notice how the angle is given to us just degrees itself. So first thing that I'm going to do is I'm going to write it as 40 degrees plus 0.32 degrees. But notice that if I go to the right side, 1 degree is equals to 60 minutes and 1 minute is equals to 60 seconds. So if I continue right here, which it is in the same line right here that I wrote here, notice that now I got 40 degrees plus 0.32 degrees. The next line, what I'm going to do is I'm going to keep the 40 degrees because I want degrees at the end. And now I'm going to multiply 0.32. I know that 1 degree is equals to 60 minutes. Now I'm going to multiply 0.32 times 60 minutes. And if you guys are using your calculators, so you guys multiply 0.32 times 60, that would give you 19.2 minutes. Now that you guys have that, I'm gonna keep the 40 degrees plus. Now I'm gonna split the 19.2 minutes into 19 minutes plus 0.2 minutes. But remember, a minute is equals to 60 seconds. So I'm gonna now substitute here. Instead of this 1 second, I'm gonna substitute that for 60 seconds. And then I'm gonna multiply 0.2 times 60 seconds. And when I do that, now what I'm gonna have is 40 degrees plus 19 minutes plus 12 seconds. Again, if you multiply 0.2 times 60, that will give you 12, and that will be 12 seconds. And if we put it together in the format of degrees, minutes, and seconds, so the final answer would be 40 degrees, 19 minutes, and 12 seconds. All right. So same procedure is done for B, but notice I have C here. So why don't you guys give a try to C? Is 61.24 degrees. So you guys got paper with you guys, give it a try. Give it a try. Let me give you a couple of minutes for you to try it. And we'll check the answer together.
What are we converting the degrees to again, Professor?
We're converting the degrees to degrees, minutes, and seconds. This is the procedure to do so.
Okay, thank you.
Sure. Just follow the same steps as you guys have in one of the exercises. All right, so first thing that I'm going to do is I'm going to rewrite the 61 degrees plus 0.24 degrees. And then I know that 1 degree is equal to 60 minutes, so I'm going to multiply 0.24 times 60 minutes, 0.24 times 60 minutes, and that is equals to 61 degrees plus 14.4 minutes. I'm going to continue here. Now what I'm going to do is I'm going to split the 14.4 minutes into 14 minutes plus 0.4 minutes. But I know that, let's see, where are we? I'm going to get rid of the chat here. I know that 1 minute is equal to 60 seconds. So I'm going to multiply now 61 degrees plus 40 minutes plus 0.4 times 60 seconds. And I'm going to multiply 0.4 times 60. That would be 24. So now what I have is 61 degrees plus 14 minutes plus 24 seconds. So if I put it together now, the final answer would be 61 degrees, 14 minutes, and 24 seconds. All right, so let me know if you guys are getting the same. All right. Perfect. Very good. Thank you guys for the feedback. All right, pretty good. So let's continue. All right. All right. So as I mentioned before, besides the degrees, also angles are measured in radians. And let's define what a radian is. So let's concentrate on this circle that I have here on the right side, right here. And notice that you guys start by drawing the circle, and then at the center of the circle, you draw an angle, which this one would be the initial side. And I have the terminal side. But in such way that when you draw the angle, you guys make sure that from the center of the circle to the one of the points of the circle, along the initial side, we have R here. And notice also on the terminal side, also from the center to from the center, or will be the vertex at the same time, along the terminal side to the one point of the circle right here is also R. So these are exactly the same length. And notice that if I concentrate on this part of this circle, which is an arc, by the way, ARC, if the length of this arc is also R, and the radius from the center to one point around the circle is also R, if these three R's that you guys see here are exactly the same length, the angle that is formed here is known as a radian. That is the definition of one radian, you guys. So you can give any values to R. If R is equals to 1 here and 1 here and 1 here, that's a radian. Or if R is equals to 3 here, 3 here, and 3 here, the angle that is formed here is 1 radian. All right, so that would be the definition of a radian. All right, now that we know what a radian is, let's try some exercises. Let's convert from degrees to radians and from radians to degrees. So, as we mentioned before, with degrees, 1 revolution equals to 360 degrees. And also with radians, 1 revolution is equals to 2 pi radians. From here, we can tell that 360 degrees is the same as 2 pi radians. I didn't write it down, but you can write it. 360 degrees equals to 2 pi radians. Based on that, also, 180 degrees is equals to pi radians. Or, notice, if we solve for 1 degree, 1 degree is equals to pi over 180 radians. If I just switch the order right here, like pi radians equals to 180 degrees, excuse me, I can also solve for 1 radian, and 1 radian is equals to 180 divided by pi degrees. So we're gonna be using these two relationships to convert from degrees to radians and radians to degrees. So for example, if we start with 30 degrees right here. Notice, since I want to convert each angle in degrees to radians, I start with 30 degrees, but I know that 1 degree is equals to pi over 180. So I'm gonna substitute the 1 degree by pi over 180. So I have 30 times pi over 180. I'm gonna cross reduce the 30 with the 180. So this 0 and this 0 divides out what is equals to 1. And 3 goes into 3, 1. 3 goes into 18 6 times. So I'm left with pi over 6. So 30 degrees is the same as pi over 6 radians. All right. So let's try together 45 degrees. 45 degrees. So let me give you 1 minute for you to try it. 45 degrees. Let's see what would be the equivalent of 45 degrees in radians. You know, and also try the 60 degrees. Let's try 45 and 60 degrees. Let's try them together. Let me give you a couple of minutes for you to try it.
Do you want us to write our answers in the chat?
You can do so and share it to me, or sure, yeah, definitely. Why not?
All right.
Definitely. Yeah, perfect. Nice. Yeah, very good. Pi over 4. All right, pretty good. Pi over 4. Yeah. 45 degrees is the same as pi over 4. Perfect. Very nice, you guys. Pretty good. All right. So, all right. Okay, you're moving ahead up to 60 degrees. Yeah, go ahead. Go ahead, please. Give a try to 60 degrees. See what you guys get. Yeah, nice. Very nice. Very nice, you guys. Perfect. So 45 is the same as 45 times pi over 180. So 45 goes into 45 once, 45 goes into 184 times. So 45 degrees is equals to pi over 4 radians. Perfect. Very good. 60 degrees, let me see if I can do it right here, 60 degrees. Is equals to 60 times pi over 180. And 60 degrees is the same. Well, this 0 with this 0 goes away. 6 goes into 6, 1. 6 goes into 18 3 times. So 60 degrees is equals to pi over 3. All right, so very good. Perfect. So notice that I did D, and it is 108 degrees, 108 degrees. So you can also try it on your own and notice that we can reduce a little bit 108 into 180, but 108 does not goes into 180. So for those specific cases, we can use our calculator, and I really want you to use your calculator, you guys. See, you guys get this this answer. You know, I'm rounding to 3 decimal places here. Just give it a try, you guys. Oh, all right. You got 3 pi over 5. I like that. Or, yeah, perfect. Or 1.888884, pretty good. Yeah. That's pretty good, by the way.
So with everyone getting approximations, that's
So
essentially
here,
just it's
here
scientific.
is just an approximation, you guys. It's not an exact answer. This is just an approximation. All right. So you notice, which we're going to be very, very familiar with, the 30 degrees, which is pi over 6, and 45 degrees pi over 4, 60 degrees pi over 3. Those are exact answers. Pretty good. All right. So let's continue now. Let's go the other way around. Let's convert each radian to degrees now. Radian to degrees. So let's start with pi over 2 radians. And what is pi over 2 radians? Well, what would be the equivalent in degrees? Well, I did A already, by the way. Notice, pi over 2 radians is equals to pi over 2, but 1 radian, we know that is equals to 180 over pi. And if we cross reduce pi with pi, which is equals to 1, and the 2 with the 180. So pi over 2 is equals to 90 degrees. So what would be 5 radians in degrees? All right. Pretty good. 900. Are you guys getting 900? Is it 450 or 900, you guys? So, oh, interesting. Remember, it is 5 radians, okay? It's 5 radians. All right. So, let's do it together here. It is, let me get rid of the chat here, you guys, for 1 second. So I have 5 radians, all right? So I'm gonna multiply, well, it's 5 radians. So I'm gonna multiply the 5 times what? 180. Okay. Over pi. It's just 5 radians, okay? Sorry about that. It's just 5 radians. So that would be 5 times 180 over pi, right? So what is 5 times 180? 0 is 40, that's 900 divided by pi, right? And here we can get an approximation. What is 900 divided by pi? 900 divided by pi. And I got 286.48. I'm gonna round it to 2 decimal place. All right. So that would be degrees, by the way. Degrees. Yeah, divide by pi. Yeah, definitely. All right. Everybody got something similar to that, you guys? All right, perfect. Yes, sorry about my writing. It's just 5 radians, okay? Barry, this should be 900. Well, remember that it is 5 times 180 over pi. So 5 times 180 is 900, but we have to also divide by pi, which give us 286, an approximation of 286.48 degrees. Ready? Okay. So now let's try 3 pi over 2 radians. Let's see what we get, you guys. 3 pi over 2 radians. All right, so let's see. All right, perfect. All right, Jay, pretty good. All right, Layla, perfect. Very good. All right. Right, perfect. Very good, you guys. All right. 270. All right, pretty good. 270. All right, pretty good. 270. Three pi divided by 2 times 180 over pi. The pi's divide out. 2 goes into 89. I'm left with 90. And that would be what? 3 times 9 is 270 degrees. Pretty good. All right, so let me know if you guys have any questions and how to convert degrees to radians, radians to degrees, or what we did before from degrees to minutes and seconds, or the other way around, degrees, minutes, and seconds to degrees. Let me know if you have any questions on how to do that. So it seems that if you guys don't have any questions on how to do this conversion, so we're done with 6.1 and let's continue with 6.2, by the way. All right, let me get the handouts from 6.2, which they're right here. Okay, so let me just. All right. All right, so we're gonna continue with 6.2. You guys have your handouts with you right there. Let me just get rid of this chat right now. 6.2 is trig functions. We're gonna start with the trig functions right now. And we're gonna start with the unit circle approach, the unit circle approach. By the way, there are more than one approach for the trig functions, this is just one of them. All right, so let's start by reviewing the equation of the circle with center at the origin. Notice, if we remember, the equation of the circle with center at the origin is x squared plus y squared equals to r squared. If we make the radius equals to 1, now we have the unit circle. So the equation of the unit circle is now x squared plus y squared equals to 1. So again, here the radius is equals to 1. And that would be the unit circle. All right, so in this figure, we have the unit circle. And notice that along the x-axis, y-axis, the radius is equals to 1. The radius is equals to 1 from here to here, from here to here, excuse me. In either side is 1. from the center on the left side of the on the x-axis is -1. On the y-axis, from the center down is -1. So all around, the radius is equals to 1. But let's say that we have a point on the unit circle, and that point is an x, y point. And we have that point somewhere around the circle. Let's pick a point, a place for the point, which is, let's say, right here. If I project this point down on the x-axis, which from here to here would be y, and from the center to this point would be the value of x. Notice that if we connect the point to the center, now we have a radius of equals to 1, and we have one of the sides of this triangle. Notice this triangle now becomes a right triangle, by the way. And based on this triangle, we can find the trig functions. Also notice that here, let me use this color right here. This arc right here is, I'm using T here. But notice also here inside the angle that is formed, here is theta. Notice that theta is the same as T, by the way. So from here, we're going to find the trig functions. And I'm going to start by stating that let P be a point on the unit circle, which is x, y, would be any point. Be the point on the unit circle where T is equals to theta. So if I want to state the sine function, sine of theta, I can use sine of theta or sine of t. It's either or, that would be okay. Sine of theta is equals to y over 1, which is the radius. And notice that is the same as sine of theta equals to y by itself, because y divided by 1 is y. If we continue with the cosine function, cosine of theta now is equals to x over 1, which is the same as cosine of theta equals to x. So sine of theta equals to y, cosine of theta equals to x. Notice also, based on these two definitions that we found right now, I can also state that here, any point around the unit circle is the same as cosine theta, comma, sine theta. If we continue with the tangent function, tangent theta is y over x, assuming that x is different from 0, otherwise this becomes undefined. And the cosecant function, CSC, cosecant of theta, is equals to 1 over y. By the way, one observation, notice if we go back to the sine, which is right here, and the cosecant, notice that these two are reciprocal of each other, by the way. Here is y over 1, and cosecant is 1 over 1. Notice the secant function, secant theta equals to 1 over x, where x cannot be 0, by the way. Let's compare now the cosine function and the secant function. Notice cosine theta is equals to x over 1, or just x. But the secant, yes.
Can you move the page up?
Oh, sorry about that. Thank you, you guys. Thank you for the observation. Just jump in, you guys. Thank you. Thank you. Yes. So I was telling you about the sine and cosecant, you guys. Notice the sine. Theta is y over 1, and the cosecant is 1 over y. These two are reciprocals of each other, the same as cosine, which is x over 1, and the secant, which is 1 over x. And also, notice, the cotangent function, cotangent theta is x over y. Compare cotangent with tangent, by the way. Tangent is y over x, and cotangent is x over y. All right? So that's how we got 6 trig functions: the sine, cosine, tangent, cosecant, secant, and cotangent. So that would be the 6 trig functions that we're going to get very, very familiar with. All right, so let me know if you have any questions so far. If not, we'll continue to the next page.
Professor, can you give us like just a minute to copy down those?
Sure,
the 6?
definitely. Yes, definitely, you guys. Definitely. Definitely. Again, just to let you know, some of you already know, I have uploaded these notes in Canvas. You guys can download it later. You can write it right now. It's up to you. Oops, excuse me. I don't know what I did here. All right. Huh. Okay, I did. So let me see. I did something here. All right.
There we go.
All right.
Thank you.
We're ready? Okay, perfect. So let's continue, and let's try an exercise with these 6 functions, trig functions. It says find the exact values of the 6 trig functions of t. Remember, t is the same as theta, by the way. And let's try A together. Let's go over A here. So notice a point is given. So this point is around the unit circle, by the way. In this point, the x value is square root of 3 divided by 2, and the y value is 1/2. Again, this is on the unit circle. Because this is on the unit circle, r is equals to 1. All right? Okay. So by definition, we know that sine of t is equals to y, right? If you go back to definitions, sine of t is equals to y, so sine of t equals to 1/2. And we mentioned that the cosecant is the reciprocal of the sine, so I can find the cosecant by knowing the sine. So cosecant of t would be the reciprocal of 1/2, so the reciprocal of 1/2 would be 2, right? Same idea here for the cosine of t. Cosine of t, we know that cosine of t is equals to x, right? And x happens to be square root of 3 divided by 2. So I know that the reciprocal of the cosine is the secant, so I can find the secant. So the secant of t is the reciprocal of the cosine of t. All right? So the reciprocal of square root of 3 divided by 2 is 2 over square root of 3, right? But notice, I got 2 over square root of 3. Since we have a square root of 3 in the denominator, we're going to rationalize the denominator. Remember rationalizing the denominator? What is rationalizing the denominator? Getting rid of the radical. That's what rationalizing means. So in order to rationalize the denominator of the secant, I'm going to multiply square root of 3 times square root of 3 in the denominator, but also I'm going to multiply the numerator times square root of 3. When you multiply square root of 3 times square root of 3, that would be square root of 9, and square root of 9 is equals to 3. That's why I have the 3 by itself in the answer. In the numerator, I'm left with 2 times the square root of 3. That would be secant of t. So from now on, every time that we have a radical in the denominator, we're going to rationalize the denominator. And it's done in this way that I show you guys. If we continue now with the tangent, so now how do we find the tangent? Tangent of t. Well, by definition, tangent is equals to y over x, right? So notice, what is y? 1/2. What is x? Is square root of 3 divided by 2. So it's 1/2 divided by square root of 3 divided by 2. And notice here you're dividing a fraction over a fraction. And remember that when you are dividing two fractions, when you multiply the outer values, which is 1 and 2, that would be our new numerator. And if you multiply the inner values, 2 times the square root of 3, that would be our new denominator. So by doing that, I end up with 2 divided by 2 square root of 3. Notice if we divide 2 by 2, that's equals to 1, and I'm left with 1 over square root of 3. Again, I had to rationalize the denominator here by multiplying by square root of 3, both the numerator and the numerator, both the denominator and numerator. And if after I do that, I'm left with square root of 3 divided by 3. So tangent of t is equals to square root of 3 divided by 3. Same idea here to find that was the tangent of t, which is the reciprocal of the tangent. Notice I'm using this answer right here to write the cotangent of t, which is the reciprocal of this value, which is 3 over square root of 3. Again, we're going to rationalize the denominator by multiplying by square root of 3, then the denominator and numerator. And I'm left with 3 times the square root of 3 divided by 3. And at the end, I'm left with a square root of 3 only. Okay, so again, a rule from now on, we're going to rationalize the denominator. Let me know if you guys have any questions. Oops, excuse me. I don't know what I'm doing here, you guys. Let me go back here. All right, I'm going back here. All right, perfect. Pretty good. All right, so let's try one on your own. We're going to try one. And we're going to try D. Let's try D. Let me give you a couple of minutes for you to try D. And then after this exercise, we're going to take a break. So let's try D. Again, this is a point along the unit circle. So let's try D. Oops. All right. Pretty good. Thank you guys. Let me know, okay? And sometimes I get into this and I don't pay attention where the page is, but yes, please let me know. You know, very good. Thank you. All right, so let me catch up to you guys. So we have X and Y. And I know that R is equals to 1, by the way. If I want to start with the sine, let's say, let me start with the sine of t. That would be equals to negative 2/3. Don't get confused with the negative. The negative, you can place it either in front, you can place
Hey,
it.
Professor, your
Yes.
camera, it's out of focus.
Okay, I'll, yeah, thank you guys. Let me, right there, thank you. Very good, thank you. All right, so again, with the negative, don't get confused. You can put it in front of it. You can put it in the numerator. You can put it in the denominator. For example, I can write sine of t as negative 2/3. That would be okay. I can get the reciprocal of the sine, which is what? Cosecant of t, which is what? Negative 3/2. Okay, I got the sine. Then I can get the cosine of t, which is negative square root of 5/3. And the reciprocal of the cosine, which is the secant, by the way, it is the secant, and secant of t is equals to 3. Again, here you can place the negative in the numerator, and that would be negative 3 divided by the square root of 5. But notice we have the square root of 5, so let's rationalize the denominator square root of 5. So again, to rationalize the denominator, multiply by the square root of 5 each the numerator and the denominator. And this is the same as negative 3 times the square root of 5 divided by 5. And that is secant of t. All right? Okay. So if we continue now, let's find the tangent of t, which by definition is y over x, right? And that would be negative 2/3 divided by negative square root of 5 divided by 3. Notice that we are dividing a negative by a negative, so that's going to become positive. And if I multiply 2 times 3, the outer values, that's my new numerator. And if I multiply the inner values, which is the square root of 5 times 3, that becomes my new denominator. So 3 divided by 3 is equals to 1. And I'm left with 2 divided by the square root of 5. But notice I have to rationalize the denominator again. Interesting. Let's do that. Let's multiply by a square root of 5 times the square root of 5. And I'm left now with 2 square root of 5 divided by 5. So that's the tangent of t. Tangent of t. All right. All right, so now let's find cotangent. Let's find cotangent of t. Cotangent of t, cotangent of t is the reciprocal of tangent of t. So I'm gonna use this value here, and the reciprocal would be 5 over 2 square root of 5. But notice I still have a radical. So to get rid of the radical 5, I'm going to multiply by square root of 5 times square root of 5. And that is equals to 5 divided by, 5 times square root of 5 divided by 2 times 5. This 5 with this 5 divide out. And cotangent of t is equals to what? Square root of 5 divided by 2. All right, and that would do it. Excuse me, let me just put it right there. All right, so any questions that you guys might have? So again, we're working with a unit circle right now. So we always assume that the radius is equals to 1, r is equals to 1. Let me know if you have any questions. If we don't, so let's take a 10-minute break. Let's take a 10-minute break, and we'll be back in 10 minutes. Ready? Okay. So let me stretch myself. You guys do the same. Get a glass of water, and we'll be back in 10 minutes. It's 6:36, 6:46. All right. All right, so let's continue here. Now what you guys see is the unit circle. So we're gonna get familiar with the unit circle. You guys downloaded the, I posted the unit circle also in Canvas, by the way. My recommendation is download it because we're gonna practice the unit circle and we're gonna learn the unit circle. It says write the degree measures on the dotted line, the radians measured in terms of pi on the solid line in the x, y coordinates in radical form for each angle in all 4 quadrants of the unit circle. Do not use decimal approximation. All right, so we're gonna start with the unit circle, by the way. If you don't have this form with you, you can draw it on your notebook right now. But notice that, by the way, the radius is 1 from here to here. So this is the x-axis and the y-axis. So let me start making some notes here. So we're gonna start with quadrant 1, by the way. Notice we have 4 quadrants, 1, 2, 3, and 4. Let's start with quadrant 1, and we're gonna start at this point right here. Notice this point, since the radius is equals to 1, here we're gonna have 1, 0. All right. So it says that in the solid line, write the degrees measure on the dotted line, the radians measure in terms of pi on the solid line. Notice that here, since we're gonna start here, this would be 0 degrees. And here would be 0 radians right there. So notice that this line right here, it partitions 90 degrees in 2, which is, this is the 45-degree line, by the way. The line below it is the 30-degree line. This is the 30-degree line. This is the 45-degree line. And this is the 60-degree line, counting from the initial side. This would be the initial side. Going counterclockwise this way. So here, we're gonna have 30 degrees, 45 degrees, and 60 degrees. Here, we're gonna have 90 degrees. All right. Now let's continue with the radians. So we know that 30 degrees, we did an exercise, 30 degrees is the same as radians as pi over 6. 45 degrees is the same as pi over 4. And 60 degrees is the same as pi over 3. So we also know what 90 degrees equivalent in radians, and that would be pi over 2. All right. So notice at pi over 2, which is 90 degrees, this point right here is what? 0,1. Remember this point, let me just write it right here. This is cosine theta, comma, sine theta. For this specific point right here, cosine theta is equals to 0 and sine theta is equals to 1. For this point right here, cosine theta is equals to 1 and sine theta is equals to 0. All right, so again, we start at 0, 30, 45 degrees, 60 degrees, and 90 degrees. Now we go around and we're gonna continue around the circle. Now, the values that continue here are gonna be multiples of these values, multiples of 30, multiples of 45 degrees, multiples of 60 degrees. Well, notice 60 is a multiple of 30 degrees, by the way. 45 degrees is a multiple of 90 degrees. So let's continue. We're gonna continue this way, counterclockwise. And notice, what is 90 plus 30? 90 plus 30 is 120 degrees. But notice that from 30 to 45, there are 15 degrees, by the way. So what is 120 plus 15 degrees? That is 135 degrees. All right. So from 45 to 6 is also 15 degrees. What is 135 degrees plus 15? That would be what? 150 degrees. And now we're along the x-axis by the other sides. So 150 plus 30, that would be 180 degrees. So let's finish the degrees and then we'll continue with the radians. So again, if we continue now, well, let me just write this point right here. What would be this point right here? Well, this point would be what? -1 and 0. All right. So what is 180 degrees plus 30 degrees? That would be 210 degrees. What is 210 plus 15? 225 degrees. What is 225 plus 15 degrees? That would be what? 240 degrees. What is 240 plus 30 degrees now? 270 degrees. All right, so let me stop right there. All right. Let me see if anybody has any questions here. All right, okay. Perfect, very good. All right, so let's finish now. What is 270 plus 30 degrees? That would be 300 degrees. What is 300 plus 15? 315 degrees. What is 315 plus 15? That would be 330 degrees, 330 degrees. And what is 330 plus 30? That would be 360 degrees. All right, so that would be the degrees around the unit circle. Now let's continue with the radians. So again, we start with pi over 6, pi over 4, pi over 3, pi over 2. Again, these are going to be multiples also of pi over 6, pi over 4, pi over 3, and pi over 2. So if we do the max, like we said that from here to here 30 degrees, which is the same as pi over 6. if we add pi over 2 plus pi over 6, we're going to find the value that goes right here. Okay. So the value that goes right here, that's going to be a multiple of pi over 3. So from this point to this point, excuse me, if we start at the initial side, from here to here is 60 degrees, and from here to here would be another 60 degrees. So in radians, here from here to here is pi over 3, and from here to here is another pi over 3. So if we add pi over 3 plus pi over 3, that would be 2 pi over 3. And notice that if we start to relate in a reference always going to be the first quadrant, by the way. Notice if we start with pi, the denominator of 3 right here, the next denominator right here is the denominator of 4, which corresponds to a multiple of 45 degrees. So here is going to be, the denominator equals to 4, but it's going to be a multiple of pi over 4. So here's pi over 4. Here is 2 pi over 4, which is a multiple of 45. So here would be 3 pi over 4. So here is pi over 4. Here is a multiple of 45 is a multiple of 90. Pi over 4 is a multiple of pi over 2. So this is pi over 4. Here is 2 pi over 4. And here will be 3 pi over 4. So let's go over 150 degrees, 150 degrees. Here is a multiple of pi over 6, by the way. So if we start pi over 6 here, is pi over 6 here, 2 pi over 6 here, 3 pi over 6 here, 4 pi over 6 here, and 5 pi over 6. Since this is 180 degrees, we know that that's equals to pi. Okay. All right. Notice, compare the denominators with the radians. Notice, in the first quadrant, we start with 6, 4, 3, and 2. But now, notice how it repeats again. In the first quadrant, we ended with the denominator of 3. The second quadrant, we start with 3, 4, and 6. And this is like a pattern, you guys, by the way. Notice. In the third quadrant, by the way, I'm going to start with the denominator of 6, and then denominator of 4, and then denominator of 3. Is that clear, you guys, the pattern? So let's get the pattern that it goes here. So what will be the value here in the numerator now? Notice here I got 5 pi over 6 plus 30, that here would be 6 pi over 6 plus 30 would be 7 pi over 6, 7 pi over 6. So now we got 5 over 6. Now here we have a multiple of 45 degrees, or pi over 4. So here we got 3 pi over 4 plus 1/4 would be 4 pi over 4 plus pi over 4 would be 5 pi over 4 here. Now here is a multiple of pi over 3, which is the same as 60 degrees. So here we got 2 pi over 3. Here would be 3 pi over 3, and here would be 4 pi over 3. For 270 degrees, and we did that conversion before. Since here is pi over 2, here is, by the way, here is pi over 2, here is 2 pi over 2, here would be 3 pi over 2, by the way. Alrighty. So for the fourth quadrant, you guys, for the 300, now here, notice this is a multiple of pi over 3, which is 60 degrees. From here to here is pi over 3. So 4 pi over 3 plus pi over 3, here would be 5 pi over 3. For the 315, this is a multiple of 45 degrees or pi over 4. Since here we have 5 pi over 4, here would be 6 pi over 4, here would be 7 pi over 4. All right. So the next here is a multiple of 30 degrees, by the way, 330 degrees, or multiple of pi over 6. So here I got 7 pi over 6. And here I got 8 pi, 9 pi, 10 pi over 6. And here would be 11 pi over 6. And last 360 degrees, here would be 2 pi. So now let's recognize some patterns, all right? Because we need to memorize the unit circle. We need to memorize all these values, but always helps if we have a pattern to follow. And probably for the degrees, might not be that difficult, but for example, for the radians, myself, I have a pattern. Notice the first quadrant, I don't think that would be difficult for anybody here. But notice the denominators follow a pattern as I told you, right? You end up with 3 in the, in the first quadrant, and then you start with 3, 3, 4, and 6. In the third quadrant, then 6, 4, and 3. And then the fourth quadrant, 3, 4, and 6. Probably you guys follow that pattern in the denominators. Now, let's go back to the numerators in the radians. All right. Notice in the second quadrant, notice that when we start with the numerator 3, in the second quadrant, always the numerator is 1 less than the denominator. Everybody, notice. The numerator is 1 less than the denominator. The denominator here is 3. Now here I got 2 pi. Let's continue here. The denominator is 4 here. The denominator is 1 less, which is 3 pi. Here the denominator is 6. The numerator is 1 less, 5 pi. See that pattern right here, you guys? All right. For the third quadrant, you guys. For the third quadrant now, start with the denominator. Now the numerator is 1 more than the denominator. 1 more. If the denominator here is 6, the numerator is 1 more, 7 pi. Here the denominator is 4, the numerator is 1 more, 5 pi. Here the denominator is 3, the numerator is 1 more, which is 4 pi. Well, again here, 270, the numerator is 2, the denominator is 1 more, 3 pi. Alrighty? Okay. The fourth quadrant does not really follow like a pattern, but these values, I kind of memorize these values myself, or I do the math of like 2 pi is the same as 12 pi over 6, 1 less 1 pi, that will be 11 pi over 6. You can do the math here. Or just memorize that now we have 5 pi over 3, 7 pi over 4, and 11 pi over 6. Or do a little bit of math to remember the radians here. So Let me stop right here. Let me see if I get any questions so far. Let me focus right here. Right there. All right, so it seems that we're fine. Now let's find the values, the corresponding value of the trig function now. So here again, we're gonna be writing the values like if we start back here, you guys. If I start back here, notice here always goes cosine theta and sine of theta. So for example, what is cosine of theta here? Cosine of theta is equals to 1. What is, well, cosine of 0, let me be more specific. Cosine of 0 is equals to 1, and sine of 0 is equals to 0, by the way. So what would be cosine of 30 degrees? What is cosine of 30 degrees? Well, cosine of 30 degrees is square root of 3 divided by 2. Sine of 30 degrees is equals to 1/2. Now let's find the cosine of 45 degrees. Cosine of 45 degrees, that is square root of 2 divided by 2. And this sine of 45 degrees happens to be the same, square root 2 divided by 2. If we continue with the cosine of 60 degrees, the cosine of 60 degrees is equals to 1/2. And the sine of 60 degrees equals to square root of 3 divided by 2. By the way, if you compare these two values for the sine and cosine of 30 degrees with the cosine and sine of 60 degrees, notice that the values from here to here are switched. Okay. So we're gonna follow a pattern here, notice. And let's start with the sine and cosine of 30 degrees right here. Notice, I started with, let's concentrate on the cosine. Notice, the denominator is the same, by the way. It's always 2, notice, 2, 2, 2. But notice, let's start with the cosine. Notice, square root of 3, square root of 2, square root of 1. Here, let's say that we're going in descending order. 3, 2, and 1. Don't forget the radical, okay? Now, let's go over the values of the sine here. Again, the denominator is 2, but now the values of sine now, it is in increasing order, 1, 2, and 3. So this pattern, you guys, repeats all over the unit circle. But let's remember also the signs around the unit circle. Like in the first quadrant, notice that the signs, all the values are positive, the sines and cosines, or cosines and sines. But what about this, the second quadrant here, for the second quadrant? Well, for the second quadrant, what is the sign of the x value? Well, the sign of the x value is negative. The sign for the y value is positive, so we have a negative and positive. So let's find also the signs for the third quadrant, now that we're finding the signs. For the third quadrant, notice that the cosine is negative, and also the sine is negative. So we have negative and negative. Well, let's continue with the fourth quadrant. What would be the sign? So the x values are what? Positive, and the y values are negative. All right? Okay, so so notice the sign for the third quadrant and fourth quadrant, negative, negative, and positive, negative, okay? So let me go to the second quadrant here. And I'm gonna write the values right here, but notice that the x values, the corresponding x values or the cosines are gonna be negative and the sines are gonna be positive, but we're gonna follow this pattern right here. So since this denominator is 3, so these are the same values that we're gonna write here. These values, we're gonna write them here, but now the cosine is gonna be negative. Since the denominator is 3, the same as this denominator. So now what I'm gonna have is negative 1/2 here and a square root of 3 divided by 2 here. If you have any questions, please let me know. Is that clear, everyone? And then we're gonna continue the part and notice now, if we continue with the cosine, now this one is gonna be in ascending order. Now here is gonna be negative square root 2 divided by 2 is 1, 2, 3. Negative square root of 3 divided by 2. Is that clear? Now let's continue with the signs. Notice with the sign, which is positive square root of 3 divided by 2, now it's gonna be in descending order. We started with a 3, now we're gonna go 2 and 1. Here is gonna be a square root 2 over 2, and here's gonna be 1/2. Let me stop right there, you guys. Is that clear, the pattern that we're gonna follow in order to learn, to memorize the unit circle faster and quick? Because in the future, we're gonna be memorizing this unit circle and you guys gonna be using it on your quizzes or your exams, by the way, okay? So let me go back here. All right, makes sense, pretty good. So if that makes sense, now you guys can fill out the rest of the unit circle, by the way, with this same pattern. All right, so let's give it a try. Let's give it a try. Let's follow the same pattern to finish the unit circle. So here, since the denominator here is 6, I'm gonna continue now with these values right here, but notice that these two values now are gonna be negative because now we're gonna be in quadrant 3. Now here I'm gonna be negative square root of 3 over 2 and negative 1/2. And from here, I'm gonna follow the same pattern. See, if I started with 3 here, I'm gonna go 2 and 1 here. Negative square root 2 over 2 and negative 1/2. Now here I started with 1. Now here I'm gonna be in ascending, 1, 2, and 3. Negative square root 2 over 2 and negative square root 3 over 2. Okay, so what's the point that goes here? Well, that would be what? 0 and negative 1. Now let's finish this part, the fourth quadrant. For the fourth quadrant, notice we got plus, plus, minus. So the cosine is positive, the sine is negative. So let me start up here. So here would be a square root of 3 divided by 2 with negative 1/2. Now here I'm gonna be in descending order right here for the cosines. Now I got 3, 2, and 1, square root of 2 over 2 and 1/2. And here I'm gonna be in ascending. How it's 1, 2, and 3. Negative square root 2 over 2 and negative square root 3 over 2. And that is our unit circle, you guys. These are the values that we're gonna be memorizing. So practice. Again, I uploaded a blank form in Canvas for you to download and practice, you guys. And it shouldn't take you more than 1 minute to get all these values memorized. Or I'm always gonna give you the blank form for you to fill out. So that's it for the unit circle so far. Any questions? Please let me know. but seems that we got it. All right. So let's continue with this lecture here. Now that, excuse me, now that we know the unit circle, let's continue with that. And all righty. All right. Keep your unit circle right there with you. And we're going to apply what we learned right now. And we're going to try this exercise. It says, find the exact value. Do not use a calculator. Notice. We're going to find the value of sine of 11 pi divided by 2. What would be the value of 11 pi divided by 2? Good question is it 11 pi divided by 2 on the unit circle? Excuse me. If that value is on the unit circle, all we have to do is go and look at the unit circle, and then from there directly we can find the value of 11 pi divided by 2. For example, let's say that I give you let's say sine of 5 pi over 6. Sine of 5 pi over 6. And if you look at the unit circle, sine of 5 pi over 6 is what? It's equals to 1/2. Everybody agrees? It's equals to 1/2. Is that clear? So the values that we have on the unit circle, we can refer to those values directly. But notice, good question is, do we have 11 pi over 2 on the unit circle? Going over the unit circle, we don't have that value 11 pi over 6, right? But notice that 11 pi over 6 is more than 2 pi, by the way. So how do we're gonna find the value of 11 pi over 6 or sine of 11 pi over 6? So what we're gonna do is we're gonna simplify, or we're gonna find the equivalent angle, because 11 pi over 6 is an angle, by the way. We're gonna find the equivalent angle by subtracting 2 pi. But notice, I did the math here on the right side, right here, notice. If you guys agree with me, notice that 2 pi is the same as 4 pi divided by 2, right? Everybody agrees? Why am I doing that? Because notice, in the original question, the denominator is 2, right? So what I'm going to do is, I'm going to start subtracting from what I have, which is 11 pi over 2, minus 2 pi, which is the same as 4 pi over 2. So 11 pi over 2 minus 4 pi over 2 is equal to 7 pi over 2. But notice that 7 pi over 2 is more than 2 pi. If that is more than 2 pi, so I'm going to subtract 2 pi again. So that's what I'm doing right here. So 7 pi over 2 minus 4 pi over 2, that's equals to 3 pi over 2. So in other words, sine of 11 pi over 2 is the same as sine of 3 pi over 2. Let me stop right there. And now that I simplify 11 pi over 2 as 3 pi over 2, now the sine of 3 pi over 2, I can find that value on the unit circle. All right. So what is that 3 pi over 2? Everybody, 3 pi over 2? 3 pi over 2. Do we have that 3 pi over 2? So notice 3 pi over 2, let me just bring the unit circle right here. Here is the 3 pi over 2, right here, everybody. So what is the sine of 3 pi over 2? So the sine of 3 pi over 2 is equals to -1. And that would be our answer right here. -1. Let me know if you guys have any questions. Yes, perfect. Very good. -1. All right. So very good. Thank you. So please feel free to go for it.
Hello. Can you hear me?
Professor, we can't hear you. Your mic cut off.
Hello. Can anyone hear me?
I
Yeah,
can hear you.
yeah.
Oh,
Okay, I can hear you.
His went cold.
Can you guys hear the professor?
Nope.
I can't hear him at all. No.
Oh, okay. My internet cut out.
I thought it was my microphone. I was freaking out.
Is this screen frozen, or maybe he just dropped the?
He's still talking, but I don't even
I thought
think
he
he
just
can
got
hear
up.
us.
Yeah.
Okay.
I don't know if I was just zoning out, but I thought we were going on break.
Yeah, that's why I didn't even realize he was doing the problem until I saw him talking, but I couldn't hear him. So I'm like, something's up.
Does he still have the face cam?
Yo, he's gone.
Yeah. I think he's
He
just
left.
taking care of something.
Oh yeah, maybe something came out.
He's still on my screen.
Yeah.
On my screen too.
Wait, can you guys see his face cam? I don't have
No,
one too.
I can't.
Yeah, you gotta scroll down. Can
Oh.
you-
Okay.
Oh,
Oh, he's
I can-
moving his thing now.
Hello.
Yeah.
He doesn't appear muted in the participant list, so it's not bad. Right. Gallery view? Oh, there we go.
Can you hear me?
Yes.
All
Hello.
right,
Oh yeah,
perfect.
I
Professor,
can
we
hear
hear
you.
you now.
All right. Thank you, guys. Okay. All righty.
Oh.
All right. I'm back again, right?
Yes.
All right. Thank you, guys. Thank you for letting me know.
Oh,
All right. So, sorry about that. I'm here. I'm still here. All right. So, we're going to oversee tangent of 6 pi. And I was telling you about going back to the sine and cosine functions. We're going to learn that the sine and cosine functions are periodic every 2 pi or 360 degrees, by the way. But the tangent and the cotangent, by the way, those two functions are periodic every pi, every 180 degrees, by the way. So in order to find the value of 6 pi, you can do what I did for the sine, is start subtracting 6 pi minus pi until you get to the tangent of 0. Or on your unit circle, I put it back here. Notice that in the unit circle here, we start with 0 and 1 pi. If I go around, this would be 2 pi, 3 pi, 4 pi, 4 pi, 5 pi, and 6 pi. So 6 pi is the same as 0, by the way. So what would be the tangent of 0, by the way? What is tangent of 0? Well, remember, what we learned that tangent of 0 is equals to y over x, or the same as sine over cosine. And that would be 0 over 1. 0 over 1 is 0. So for for letter C, tangent of 0 is equals to 0. That would be the answer. All right. Okay. So notice I have D, and D is a negative angle, by the way. Notice cosine of negative 3 pi over 2. Cosine of negative 3 pi over 2. What is that? All right. So since this is a negative, if we start at the x-axis or 0 degrees, instead of going counterclockwise, we're gonna go clockwise. And where is that? Where would be negative 3 pi over 2? Well, if we go this way, you guys, here is negative pi over 2, right? Do you guys agree? If I continue going this way, right here would be negative pi, right? And if I continue here, here would be negative 3 pi over 2. Here is negative 3 pi over 2. So we're looking for the value of the cosine of negative 3 pi over 2. What is the value of the cosine of negative 3 pi over 2? That would be 0. So cosine of negative 3 pi over 2, this is equals to 0. Is that clear, everyone? How we found that value? Okay, so let me check on that. All right, so let's go over E together. Notice for E, we want to find the secant of negative pi. Secant of negative pi. By the way, notice that we said that secant is a reciprocal of cosine. So secant also is periodic, and its period is also 2 pi, by the way. So notice what I did in order to find the value. So secant, notice that unless we find the value of the secant around the unit circle, we can do that. Or we know that secant is the reciprocal of the cosine. Notice I'm using that property. So I can find the cosine of negative pi on the unit circle. So notice that I can rewrite secant of negative pi equals to 1 over cosecant of negative pi. Are you guys there? Okay. So what is cosine of negative pi? Well, cosine of negative pi, what is that cosine of negative pi? Cosine of negative pi is right here, right? What is the cosine of negative pi? Well, that's -1, right? So let me just move it right here, which is -1 right here. So 1 divided by -1, that's equals to -1. So secant of negative pi is equals to -1. So from now on, you guys, if we don't see a value on the unit circle like the secant or tangent or cotangent, we can use cosine and sine to find those values. Ready? Okay, so let's continue. Now notice it says, example, find the exact value of the 6 trig functions of a given angle. Find the exact value of the 6 trig functions of the given angle. All right. So before I start with that, see the figure that I have here on the right side, right here, this figure. And notice that I have the signs that you guys already know in each quadrant. So if I want to know the signs of the trig functions on each quadrant, you guys, I use these 4 letters here. Notice I start with the C, C, A, S, T, which is cast. I always use those 4 letters to find the sign of the trig functions in each quadrant. So I start by writing cast, C, A, S, T. C stands for cosine, A stands for all, S stands for sine, and T stands for tangent. Cosine, all, sine, and tangent, that refers to the trig functions that are positive in each quadrant. By the way, if you start in quadrant 4, the reciprocal of the cosine is the secant. So the function and its reciprocal, both of them are positive. Here in quadrant 4, cosine and secant are positive, and all others are negative, by the way. In quadrant 1, all the functions are positive, by the way. In quadrant 2, the sine and its reciprocal, which is the cosecant, are positive, or other ones are negative. And in quadrant 3, the tangent and the cotangent are positive, and all other ones are negative. So this is how I know the signs of the trig functions in all the quadrants around the unit circle. All right. So with that in mind, let's try this exercise. It says, find the exact value of the 6 trig functions of a given angle. Notice the angle that is given is 2 pi over 3. So what is the sine of 2 pi over 3? So here you can look at the unit circle, and the unit circle, the sine of 2 pi over 3 on the unit circle is what? Excuse me. Is the square root of 3 divided by 2. What is the cosine of 2 pi over 3? Remember, 2 pi over 3 is the same as 120 degrees, by the way. What is the cosine of 2 pi over 3? Well, notice. For now, we can use the unit circle. Ideally, we're going to memorize all these values. So the cosine of 2 pi over 3 is a negative 1/2. All right. So what would be now the tangent? What would be the tangent of 2 pi over 3? Well, I got the value already of negative square root of 3. How I came up with this value? All right. So let me do a little bit of extra work here. Well, by definition, we know that tangent of 2 pi over 3 is the same as y over x, which is the same as sine over cosine, right? Everybody, sine over cosine. What is the sine of 2 pi over 3? Well, that is square root of 3 divided by 2, divided by the cosine of 2 pi over 3, which is equals to negative 1/2. If we go through this division, that would be negative 2 times square root of 3 divided by 2. 2 times 1, which is 2. I can simplify this 2 with this 2, and I'm left with negative square root of 3. That's how I got the tangent. Now notice, we're looking for the 6 trig functions. Now let's find the cosecant, which is the reciprocal of the sine. Let me see if I can write it right here. So the cosecant of 2 pi over 3 is the reciprocal of the sine of 2 pi over 3, which is going to be 2 over square root of 3. But remember that we need to rationalize the denominator.
Professor, move the paper
Yes.
right.
I'm sorry, again?
Move the paper to the right so it can be in the camera view.
Can you see it right there, you guys?
No, it's still out of view.
Really? Let me.
Like from our view, I don't know. Maybe it's just me, but I see more of your calculator than the paper.
Oh, really? Huh. Let me see.
It seems fine for me.
Okay.
I can see it just fine.
It's fine for me.
Okay.
No, yeah, it looks good.
It looks good?
So,
Everybody
Yep,
okay?
I fixed.
Yeah, I think you fixed it. It was kind of off a little bit, but it looks
Alrighty.
good right now.
Okay. Alrighty, so again, if we want to find the cosecant, which is the reciprocal of the sine, so that would be 2 over square root of 3. So let's rationalize the denominator by multiplying square root of 3, the numerator and denominator. So if we do that, and I'm going to do it right here, that's 2 times the square root of 3 divided by square root of 3 times the square root of 3. And that would be equals to 2 times the square root of 3 over 3. So that would be the value of the cosecant of 2 pi over 3. All right. And for the reciprocal of the cosine is the secant. So for the secant, I'm going to do it right here. I'm going to write here. Secant of 2 pi over 3, which is the reciprocal of negative 1/2, which is what? Negative 2, right? All right. And now let's find the reciprocal of the tangent, which is the cotangent. And that's going to be cotangent of 2 pi over 3, which is the reciprocal of negative radical 3 or square root of 3. That would be negative 1 over square root of 3. And if we multiply by square root of 3 and square root of 3, we need to rationalize the denominator. We're going to be left with negative square root of 3 over 3. All right. All right, so that would do it. Pretty good. All right, so let me know you guys have any questions at all. Let's see here. Okay. All right, so let's continue. All right, so last part of this section. Notice it says find the 6 trig functions, but notice now that a point is given. A point is given on a circle, but by the way, this circle is not a unit circle anymore, by the way. So the point negative 3, 4 is given. X equals to negative 3, y equals to 4. In order to find the 6 trig functions, you guys, we need to find the value of r, the radius now. But notice, in order to find the radius, we're going to use the Pythian Theorem here, or also the equation of the circle, which would be the equivalent. And in order to find r, r is the square root of, notice that being more mathematically correct would be r equals to plus minus the square root of x squared plus y squared. But since we're looking for the radius is always positive. The magnitude of the radius is always positive, you guys. So r would be the square root of let's see if I'm correct here. Yeah. The square root of negative 3 squared plus 4 squared, which is the square root of 25. And r is equals to 5 now. Now by using the value of x, y, and r, we're ready to find the value of the 6 trig functions. Notice, sine of theta is equals to y over r, which is 4 over 5. Let's find the reciprocal, which is the cosecant of theta, which is the reciprocal of the sine, which is 5 over 4. Cosine of theta, which is equals to x over r, and that would be negative 3 over 5. The reciprocal of the cosine is the secant of theta, which is the reciprocal of the cosine, which is negative 5 over 3. And the tangent of theta, which is equals to y over x, or sine over cosine, which is equals to negative 4 over 3. And the reciprocal of the tangent, which is the cotangent, and that will be the reciprocal of the tangent, which is equals to negative 3 over 4. So for this specific points, again, you guys, is not on the unit circle. So first thing that we got to do is find the value of r. So why don't we try this exercise? Let's try this exercise. Let's try B here, you guys. Let's try B. The point is 2, negative 3. Let me give you a couple of minutes for you to try. Let me fix this light a little bit here. All right, excuse me. Oops, too much light right there. All right, so let's try this exercise. Let's find the value of r first, and then from there we can find the rest of the trig functions. So let me catch up to you guys. So let's find the value of r. Do it right here. R is equal to the square root of 2 squared plus negative 3 squared. So that would be equals to 4 plus 9. And that's equals to square root of 13. So r is equals to square root 13. So let me start by finding the sine of theta, which is y over r. And that would be negative 3 divided by square root of 13. But we need to rationalize the square root of 13. So let's multiply negative 3 times the square root of 13 divided by square root of 13 times square root of 13. And that is equals to negative 3 times the square root of 13 divided by 13. That would be the sine of theta. All right, so let me find the reciprocal of the sine, which is going to be cosecant of theta. And that would be negative 13 divided by 3 times the square root of 13. Again, I'm going to multiply by the reciprocal, negative 13 times the square root of 13 divided by 3 times the square root of 13 times the square root of 13, which is the same as negative 13 times the square root of 13 divided by 3 times 13. 13 divided by 13 is 1, and this is the same as negative square root of 13 divided by 3. So that would be cosecant of theta. Cosecant of theta is negative square root of 13 divided by 3. Let me continue here. We found the sine and cosecant. Let's find the cosine. Cosine of theta. Cosine of theta is x over r. That would be 2 over square root of 13. Let's rationalize 2 times the square root of 13 divided by square root of 13 times square root of 13. And that's equals to 2 square root of 13 divided by 13. That will be the cosine of theta, by the way. So let me find the reciprocal of the cosine, which is the secant of theta. And
Professor,
yes.
Can you move the paper up a little bit?
Sure, definitely. Thank you. Thank you, guys. All right, so that's the cosine of theta that I found. And secant of theta, let me find the reciprocal of the cosine, which is the secant. I can also Yeah, I can get it from here, you guys. And I think that would be easier. That would be square root of 13 divided by 2. Very simple. Just get it from here. Because if I get it from here, I can get to the same value, but I need to simplify up here. So just get it from here is much easier, by the way. All right. And now let's find the, go here. Let me find the tangent of theta, which is y over x, which is -3/2. And the cotangent of theta is -2/3. All right, so alrighty, so those would be the values for this corresponding exercise. Let me know if you guys have any questions here. Let's see. All right. Perfect. Very good, you guys. Very good. Let me know if you have any questions here at all. Well, with this exercise, we're done with 6.2. We're gonna start with 6.3. Let's see how far we go. We're almost done, you guys. Time flies, all right? So before I forget, really, I need your feedback on this section. What is it that I can do better for you guys, okay? Thank you for letting me know when I'm writing off the screen. I really appreciate that. You know, if something happens technically, you know, and I really appreciate your feedback, you guys, okay? So let's see how far we can go with 6.3. And by the way, 6.3, let me write the title of 6.3. Let me get rid of the chat here. All right, so the title of 6.3 is, let me get it really quick, you guys. I'll let you know, but it refers to, we're gonna find the domain, the range in the period of let me get it really quick right here. It's right here. Properties of the trig functions. All right, let me write it here. 6.3, this is properties of the trig functions. That would be the title of the trig functions. All right, so let me see if that could, okay, looks better. Yeah, all right, looks better. All right, so what are some of the properties of the trig function? So let's start by finding the domain and the range of the trig functions. We're gonna find the domain and the range of the trig functions. In order to find the domain and the range of the trig functions, we're gonna be using the unit circle, which I draw right here on the left side, right there, all right? So, and I'm gonna write, or I have here again, all the functions here. Sine of theta equals to y, and cosecant, the reciprocal of the sine. Cosine of theta equals to x. The secant is the reciprocal. The tangent of theta is equals to y over x. The cotangent of theta is equals to x over y. So I have the 6 trig functions right here. So in here I have a table right here with the values of the domain and the range. But let me explain how I found this, the domain and the range. So let's start with the sine. So before we start writing the domain, remember, what is the domain of the function? By definition, the domain of a function is the largest set of values at which f of x is real. So in other words, what are the values of theta, the angle, such that the sine of theta exists? If we go around the unit circle, you guys, notice that for any value of theta, the sine exists. So the domain of the sine is from negative infinity to positive infinity, or in other words, all real values. In other words, no matter what the value of sine, or the value of the angle is, we're always gonna get a value of the sine of that specific angle. And you can always check that with your calculator. Okay. So what about the range? Okay, the range, notice the range. The range of the sine, which we said that the range is along the y-axis, by the way. Notice that the range of the sine is gonna go from -1 to +1, including the -1 to 1. What is the meaning of the range? It means that for any value of the angle theta that you guys plug in and find the value of sine, that value is always going to be between these two values, including these two values, -1 and 1. Okay. So the same is for the cosine. For the cosine is exactly the same. The domain is from negative infinity to infinity. So any value of theta that you guys plug in and you find the cosine of that specific angle is going to be also between these two values, including these two values from -1 to 1, by the way. Okay. So let me stop right here and want to make sure that everybody understands, okay, understand the domain and the range. Okay. Again, for any value that you guys choose for theta, the output is always going to be between these two values. And the period of the sine and cosine is, by the way, is 2 pi, which we're going to find a little bit in a couple of minutes, by the way. All right, so let's talk about the tangent. Notice, let's talk about the tangent. The tangent, all right, so notice. By definition, tangent, right, is y over x, which is the same as sine over cosine, y over x. But around the unit circle, you guys notice that tangent at zero is 0 over 1. But what happens for tangent of pi over 2 or 90 degrees? What is the value of tangent at pi divided by 2 or 90 degrees? Notice, the value of tangent at 90 degrees or pi divided by 2 is 1 divided by 0, which 1 divided by 0 is undefined, by the way. So tangent at 90 degrees is undefined. And the same as 3 pi over 2 or 270 degrees is also undefined. The tangent is undefined, you guys. So the tangent, the domain of the tangent, by the way, are all the values except when theta is an odd number. Let me rephrase what I said. Is all the numbers except when theta is a multiple, an odd multiple of pi over 2. That's what it means right here. Notice, this is pi over 2 plus pi times n. N if you give values to n, integer values, if n is equals to 0, you're left with pi over 2. If n is equals to 1, what is pi over 2 plus pi? That will be 3 pi over 2. If n is equals to 2, what is pi over 2 plus 2 pi over 2? That would be 4 pi. That would be 5 pi over 2, which is right here. So this would be the domain of the tangent, by the way. Now, the domain of the tangent, you guys, I'm sorry, the range of the tangent happens to be negative pi over pi. So I'm gonna stop right here, you guys. We'll continue with this section 6.3. I really appreciate. Thank you very much, you guys, and see you on Wednesday, definitely. And please give me your feedback. What is it that I can do better, you guys, or we can do better as a team? Okay. So we'll continue on Wednesday. Any questions?
Just
Wait,
about
Professor.
the. You can go ahead, man.
Oh, I just have a question about the lecture.
Yes.
So going back to the unit circle, can you explain how you got the radians in quadrants 2, like 2 pi over 3, 3 pi
Yes.
over 4?
Oh, definitely. Yes, definitely. Let me go over that. You guys, the rest, you have no questions. You free to go or have a night. And I'm gonna go over the unit circle again. Let me get it here. And okay, I have it right here. Let me just go right here. All right, you're welcome, you guys. See you on Wednesday. All right. Do you see the unit circle here?
Yes, that's fine.
All right. Tell me your name again, please.
Josiah.
Josiah, thank you. Thank you, Josiah. All right. So so here the key for the unit circle, Josiah, is the first quadrant. If you learn the first quadrant, everything else is based on the first quadrant, because everything else is a multiple of the values of the first quadrant. So if we go over the first quadrant, you know, in degrees, 30, 45, 60, and 90, 0, 30, 45, 60, and 90, right? No problem. Josiah, is it more specific on the radians, right? Is that was your question, or we can go?
Yeah, more specifically on the radians.
All right, let's go over the
quadrant
radians.
2.
Yes, definitely. So let's learn the radians on quadrant 1, right? So we start with 0, pi over 6, pi over 4, pi over 3, right? And pi over 2, which is 30, 45, 60, and 90, right? So let's go to quadrant 2 now, all right? Quadrant 2. Notice in quadrant 1, we ended with pi over 3, right? The denominator is 3 right here. So in quadrant 2, you're gonna start with the denominator of 3, and then with the denominator of 4, and then with the denominator of 6. So to write the values of the radians in quadrant 2, I'm gonna follow that pattern. I'm gonna start with writing the denominators. I'm gonna look back to quadrant 1 and notice I ended up with the 3, denominator 3. So I'm gonna start with the denominator of 3 in the quadrant 2, and then denominator of 4, and then denominator of 6. That's the first thing that I do, okay? So you know what, let me see if I have another blank. Well, I might not, but do you notice what I'm saying here, Josiah?
Yeah, I see
The
it.
pattern? All right, perfect.
Yes.
And notice now I took care of the denominators, right? Now let's take care of the numerators now. Notice the numerators, for the second quadrant, the numerators are going to be 1 less than the denominator. So notice, here the denominator is 3, the numerator is going to be 2 pi. Here the denominator is 4, the numerator is going to be 3 pi. Here the denominator is 4, the numerator is 5 pi. This is how I learned the radians in quadrant 2. The numerator is 1 less than the denominator. So I start by writing the denominators first, because that's the easier part, right? And then for the numerator, it is 1 less than the denominator. If the denominator is 3, here is going to be 2 pi. The denominator is 4, here is going to be 3 pi. Here the denominator is 6, here now is going to be 5 pi. See that pattern for quadrant 2? Josiah?
Yes.
Make sense?
Oh, so I was meant like, so when you how do you get from pi over 2 to 2 pi over 3 when you fill in the blank?
Sure. Let me go over that. Okay.
Oh, okay.
Let me go over that. Let me see here. I can try. You know what? Let me try here. I'm gonna try it here. All right. So let's say that I have the unit circle, and oops, let me put it right there. And we're gonna do it, all of it, okay? So let's say that I'm gonna start by drawing the 45 degree first, then the 30 degree, and the 60 degree, okay? And I'm gonna do the same here, here, and here. And I'm gonna do the same in the 3rd quadrant. And I'm gonna do the same in the 4th quadrant. Okay. So let's do the radians. Here is 0. Here is pi over 6. Here is pi over 4. And here is pi over 3. And here is pi over 2. Alrighty? That's quadrant 1. Are we there?
Yes. I'm with
All right,
you.
perfect. Now, what I'm going to do for quadrant 2, I'm going to start with the denominators. Notice for quadrant 1, I start with 6, 4, and 3. Okay? Don't pay attention to the 2. Now, 6, 4, and 3. Now, here, if I ended with 3, here in quadrant 1, I'm going to start with 3 in quadrant 2. And here would be 3, here would be 4, and here would be 6. Is that clear, the pattern? 3, 4, and 6.
Yeah. Okay.
You got it?
That now.
All right, perfect.
Yeah.
Now let's find the numerators. With the denominator of 3, the numerator is 1 less than the denominator. So 1 less than 3 would be 2, right? Here would be 2 pi. The same for the 4. The numerator is 1 less than the denominator. That would be, here would be 1 less than pi is 3. That would be 3 pi. Now let's continue with the 6. Again, the numerator is going to be 1 less than the denominator. 6 minus 1 is 5. Here would be 5 pi over 6.
Oh, okay. So it was that simple.
Yeah, that's for quadrant 2. Okay, so far. Is that clear,
Okay.
quadrant 2?
All right. It's clear now.
Okay, let's go over quadrant 3 now. Okay, now here is pi over 2. Here would be, well, this is 180 degrees, which is the same as pi. Let me write the pi right here, okay? Now let's do quadrant 3 together, okay? Now let's start with the denominator. Notice we got 3, 4, and 6, right? Well, let's follow this pattern. We ended up with 6. Here we start with 6. Then with 4. Then with 3. Is that clear?
Yes.
Perfect. Pretty good. For the third quadrant now the numerators is going to be 1 more than the denominators. For the second quadrant was 1 less. For the third quadrant is 1 more. If the denominator is 6, 1 plus 6 is 7. Here would be 7 pi. For 4, you can write your own notes here, okay? You can say, you know what, here denominator is 1 less. I mean, numerator is 1 less than denominator, something like that. Let's continue with the third quadrant. Again, it's 1 more than the denominator here. 4 plus 1 is 5. Here would be 5 pi. For the 3 is 1 more than 3, which is 4. Here would be 4 pi divided by 3. Let me stop right there. Is that clear for the third quadrant?
Yes. The picture's a little blurry too.
Oh, let me focus. Okay, let me. Thank you. Right there. Again, for the third quadrant, the numerator is 1 less than the denominator. If the denominator is 6, the numerator is 7 pi. If the denominator is 4, the numerator is 5 pi. If the denominator is 3, the numerator is 4 pi. That's the third quadrant. Okay. The second quadrant is 1 less. The third quadrant is 1 more than the denominators. Can you remember that pattern?
Yeah, I'm gonna definitely have to practice the patterns.
Oh,
definitely practice.
Yes, but remember that. That's how I learned the unit circle, by following that pattern, by remembering that. Okay, so make your own notes. All right, for the second quadrant is 1 less. The numerator is 1 less than the denominator. For the third quadrant is 1 more than the denominator. Okay. All right, so here now, next, since here I got pi over 2, here is 2 pi over 3, 2 pi over 2 here, which is the same as pi. Here is 3 pi over 2, which is the same as 270 degrees, by the way. Ready? Okay, so notice that I ended up with 3 right here. Now here would be 3, here would be 4, and here would be 6. So no matter what, you start with here with the first quadrant, you ended up here with 6. So start 6 here, 4, and 3 here. All right. For the fourth quadrant, Josiah, here for the fourth quadrant, here, unless you do the math here or memorize these values here, if you notice, going back to quadrant 3, here we got 4 pi over 3. So here would be 5 pi over 3. How do I found the 5 pi over 3? Going back to the third quadrant. 4 pi over 3. Next would be 5 pi over 3.
Yeah, I think that fourth quadrant was what got me more confused.
Yeah, so here for the fourth quadrant, notice, if we start with the denominator 3, Josiah, go back to quadrant 3, notice. Look at the denominator 3 right here. Notice, in the denominator 3 here, you got 4 pi, right?
Yes.
To go from quadrant 3, this is a 60 degree, by the way. To go from quadrant 3 to quadrant 4 here, from here to here are 60 degrees or pi over 3 from here to here. So if you add 4 pi over 3 plus pi over 3, you get 5 pi over 3. That's
okay, I see it.
4
Yeah.
pi over 3 plus pi over 3, because from here to here is pi over 3, you get 5 pi over 3. That's how you get 5 pi over 3.
Okay.
Okay. Now let's go over here to this, the denominator equals to 4. So notice, let's go back to quadrant 3 here. Here you got 5 pi over 4. Okay. Notice here, this is a multiple of 45 degrees, by the way. Next, here, 3 pi over 2 is another multiple of 45 degrees, by the way, or pi over 4. If you add 4 pi over 4 plus pi over 4, that would be 6 pi over 4, which is this point right here. If you simplify 6 pi over 4, is the same as 3 pi over 4. But here, keep it at 6 pi over 4. What is 6 pi over 4 plus pi over 4? 6 pi over 4 plus pi over 4, that would be 7 pi over 4 right here.
Oh, okay. Yeah, I see that now.
That's multiple of 45 degrees, or multiple of pi over 4, by the way.
Yeah.
Okay. The last one, which here is the denominator is equals to 6. There are two ways to find this value. Notice here, when we have 0 here, this is the same as 2 pi. All right. Is that clear?
Yes.
2 pi. Well, 2 pi is the same as 12 pi over 6, right?
Yes.
Correct? Well,
Correct.
notice, what if we subtract pi over 6, which is from here to here is pi over 6. What is 12 pi over 6 minus pi over 6?
Oh, 11 pi over 6.
11 pi over 6. That's the value here.
Oh, okay.
Alrighty?
All right. Okay.
So that's how I find those values right there. But
Okay. Yeah. I was just gonna. I was just confused on how to get from quadrants 2 to 3 to 4, but it all makes sense now. I just wanted a clarification on
No
that
problem.
unit circle.
Perfect.
But
So-
thank you, Professor. I just
you're
want to.
welcome.
I'm gonna be practicing a
Yes.
lot of this. And sorry if I cut off someone else.
No,
if they want to ask you a question.
no problem. Let's see if anybody else has any other questions. So practice, practice, and practice.
Okay, I will. See you on
Alright.
Wednesday, Professor. Thank you
Definitely.
for hosting.
You're welcome.
Yeah.
All right, you're welcome. Mm-hmm.
All right.
I have a question, but
Sure.
it's not about to do with the lesson. So,
Mm-hmm. Yes, I'm here.
okay. Well, it was about the exam uploading. So I wasn't able to like upload the exam. I sent you an email already about it.
Yeah. So if you go, if you go to Canvas,
Okay.
and you go to assignments.
Yeah. Is it unlocked? After the 4:30 deadline, it was locked. I wasn't able to access it anymore.
Oh, I see. So let me do something here. Okay. Okay. Let me ask. There's more students here. If anybody else has any other questions, so I can go and unlock it for you right now. Excuse me.
Okay.
And then you're gonna be able to. But basically, what you're gonna do is go to Canvas and go to assignments and click on exam 2. As soon as you click it, you're gonna be able to see a upload or submit exam 2, something like that.
Okay.
You're gonna click it right there, and when you click it right there, now you're gonna see a way to you're gonna see somewhere choose the file. So click on that, and then from there you're gonna be able to choose where the exam 2 is and which file the exam 2 is, and then it's gonna also let you to upload it from there.
Okay.
And just click upload it, and then you're gonna be able to upload it from there. And that's it.
Okay.
That's it. That's all it takes.
Okay.
So let me
Yeah.
see if anybody else has another questions, and then
Okay.
I can go in and you know what? Probably I can use another computer to do it
Professor?
right now. Yes. Omar. Yeah.
What I was just gonna ask is that when you're doing when you're grading the test,
Yes.
since like the PDF scanner, like since papers, like I did it on paper,
Yes.
and papers like it reflects light, so like sometimes like it might be hard to read. I was
Oh,
just
okay.
saying if you have like any trouble like reading mine, I can send you the I can just resend you like anything.
All right. Thank you.
Alright.
Sure, no problem. I will let you know. I myself, I'm using this application, which is pretty cool, by the way. It's known as Tiny Scanner, and I'm using my phone to upload all those PDFs that you guys have with you guys.
Yeah.
I'm using that in I mean, it's really nice, you know.
I took a PDF scanner too.
Perfect.
Wait.
Very good.
All right.
So if anything, I will let you know, Omar. Thank you for letting me know.
Wait, Professor, you said you're using Tiny Scanner? Sorry.
Yeah, that's an application.
Tiny?
Yeah.
Okay, because I downloaded like Easy Scan or something like that.
No, that's cool.
So,
doesn't matter which one. Yeah, I'm using that one, and I see very easy to use, and the files that you guys I uploaded in Canvas. I use that application, and it's very easy to use. But any application that
the
you
PDF
guys are familiar
scanners
with.
just turn your photos into PDF files.
Yes, that's all it does. Yeah, that's all it does. Yeah,
well,
definitely.
Have a good night, Professor.
Yes. Any other questions, you guys?
Here, sorry, go ahead, man. Mine's not related to like the class. It's just the apps. So my bad.
Sure. Anybody else? Kevin, did I answer your question on the applications? Is that
yeah?
Perfect.
Yeah, thank
Very
you.
good. Very good.
Yeah,
Very
I was
good,
just having
Kevin.
some trouble, like the uploads were failing or whatever, and then I ran out of time. So that's pretty much it.
Were you be able to upload the exam?
I am.
Okay, so because
it just says.
Give me one sec. Give me one sec. Let me. It seems that I need to unlock it. Give me one sec. Let me get my other computer to do it at the same time. Give me one second.
Okay.
Please.
Okay. Okay.
So let me just do it right here. Okay, let's see. All right. Oh, let me see. Let me go there. Right now. Right now. Yeah. Right there. Okay, let me just go there. All right here. Just go here. Okay. All right, so Kevin, seems that I unlock it. Seems that you guys are good to go. All right, perfect. All right, so let me see.
Okay, Professor. I uploaded it. It seems to have worked right now.
Perfect, perfect. Also, Liliana, yeah, you can go ahead and give it a try. All right, perfect. Very good.
Yeah,
All
it
right,
looks like everything's up. Thanks so much,
perfect.
Professor.
Oh, you're
Appreciate it.
welcome. All right, you guys don't have any more questions, so we'll keep in touch on Wednesday.
Okay.
All righty. All right. Good night, you guys. Thank you.
All right.
Again.
Thanks so much. Good night.
Good night. Bye-bye.